Aloha, I'm Kamaka. Thank you for joining me on my channel, Aloha and Chill Ohana. And this playlist, Discoflowers, is all about the relationship between math and music. This video is going to be an overview on sacred geometry and phi. And if you want to be the grand architect of your own universe someday, you kind of have to learn geometry. If you want to build lots of cool stuff and create amazing worlds, geometry is the very basis of architecture. Remember from my last video, there's 4 ways that we experience numbers. Numbers, music, or numbers in time, which is music, numbers in space, which is architecture and geometry, and 4 was numbers in space-time, which is astronomy. So this video is all about geometry or numbers in space. Okay, I feel like I need to like bring it in a little closer to tell you this. So if you want to be the grand architect of your own universe someday, you must study geometry. Geometry is the very basis of architecture. It's the very basics that you need to learn. It was Goethe, an 18th century artist, that said architecture is frozen music. When you start getting into atomic theory, because that's what it is, a theory, you find that there's no particles at all. There's no matter. It's just a bunch of empty space and vibration. There's no particle or material at all. There is only vibration. So even a plain old rock is vibrating. It has a song and a dance. Is a rock sentient? Can it manipulate space and time? I don't think so. All vibration can be measured in numbers. Therefore, all life has a code, just like a computer programming code. Geometry, architecture, and astronomy are all expressed in the same language as music theory. This applies to all circular, angular, degree, and ratio-based systems of measuring. 2 examples of circular measuring is a clock, which we all use every day, and a compass rose, which before cell phones and Google Maps, people had to actually use a compass to figure out what direction they were going. The universal laws of harmony and proportion govern all of the material world. As above, so below, as within, so without. All of life is a fractal universe. Mathematics is the language of this light matrix, just like an operating system on your computer. And the primary computing code of this fractal matrix is the 1260 base system out of Sumeria. The math of form, navigation, and time, also known as sacred geometry. Sacred geometry has many aspects. Some of them are the golden ratio, Fibonacci sequence, platonic solids, the tectactress, the factor 9 grid, scalar waves, frequency, which is sinusoidal waves, sine waves, and harmonics, and also the circle of fifths is a big part of sacred geometry. The golden ratio is also phi. Phi is the 21st letter of the Greek alphabet. Phi is equal to 1.618. 0.618 is a little bit more than half. So if you take a stick and you aim roughly to break one side a little bit larger than half, it's about 1.618. Sorry, 618. But this ratio of 1.618 occurs all over nature, especially in the dimensions of plants and animals. So that would be a fun homework assignment. Something that you can do is just go on Google and research the golden ratio in nature. And you're going to find all kinds of examples. Leonardo da Vinci demonstrated the golden ratio when he used the Vitruvian Man. Leonardo da Vinci was all into sacred geometry, so you should check him out. Next, we have the Fibonacci sequence. Every number in the Fibonacci sequence is the sum of the prior two numbers. So if you start with 0 and 1, the sequence goes like this. 0 plus 1 equals 1. 1 plus 1 equals 2. 1 plus 2 equals 3. 2 plus 3 equals 5. 3 plus 5 equals 8. 5 plus 8 equals 13. 8 plus 13 equals 21. 13 plus 21 equals 34. And we can continue this pattern into infinity. So the first 8 numbers in the Fibonacci sequence are 1, 2, 3, 5, 8, 13, 21, and 34. So next, instead of deriving the sums of each number plus the number that came before, this time we're going to take each number and divide by the number that came before it, so that we get a succession of ratios. And if you examine these ratios, you'll notice that they keep getting closer and closer to the golden ratio of 1.618, but never quite reach it. If you look at the bottom line of numbers, you have 1 divided by 1 equals 1. 3 divided by 2 is 1.5. 8 divided by 5 is 1.6. And 21 divided by 13 is 1.615. So you start at 1 and you're getting closer and closer and closer to 1.618. Then if you look at the top line, you have 2 divided by 1, which is equal to 5 divided by 3, which is 1.666, 13 divided by 8, which is 1.625, 34 divided by 21, which is 1.619. So every other ratio is getting closer and closer to 1.618. So the Fibonacci sequence is like someone chasing after their lover into infinity and never quite catching that tail. So you might be asking yourself, why does any of this matter? And how does this apply to actual life? Hello, the word matter refers to the material world, and here we are talking about this code that we need to know so that we can navigate better in the material world. One interesting thing is that the number of petals on flowers correspond to the numbers in the Fibonacci sequence. So a cool homework project would be to look up how many petals your favorite flowers have and see if those numbers line up with the Fibonacci sequence.